Hello everyone, we are glad to be a part of this event and present our work. So, the title of our paper is Mathematical, Algorithmic and Software Support for Signals Wavelet Detection in Electronic Communications. Authors Lilia Khvostivska, Mykola Khvostivsky and Irina Dedyuk. An important problem for scientists in the field of electronic communications research is the process of reliable detection of useful signals as the first stage of further processing of the signal with the accurate determination of useful signal in its composition. For detect signals are used computer tools, in particular the software which is implemented on mathematical support, in particular correlation, cross-correlation, neural networks, synthesis, component and wavelet processing in the moral basis. All of the mentioned methods, except for wavelets, do not make it possible to research fluctuation process in the structure of the studied signals, which is actual the detection and subsequent identification of useful signals in electronic communications with noises when taking into account the parameters of time variability and time shifts. In electronic communications of the linear type, signals are described by an additive image which is shown in figure 1. The image of the signal model provides a description of such signals in electronic communications through the summation of noises that are formed by external internal influence. Figure 2 shows an amplitude modulated signal with noise. The amplitude modulated signal is characterized by randomness due to noises and repeatability of the modulation process during transmission. The values of amplitude of the signal change in time with the value of a certain deviation in relation to the average value of the useful signal, which leads to fluctuation sink as can be seen in figure 2. If you study the fluctuation sink of the signal in time-space, then accordingly you can quickly detect useful signals in an interfering environment. Methods of wavelet transformation with different bases constructively provide the process of studying fluctuations in the structure of signals at different time scales. The core of the wavelet signal detection method by its wavelet processing is based on the following expression 1. The mother basis function in expressions 1 provides the definition and study of the fluctuation process in the signal. Mexican head and Morlet as present functions are structurally similar to real modulated signals taken into account the indicator, so the use of these functions of correlation from signals is well. The Mexican head function is formed by double differentiation of the Gaussian function, expression 2. An example of the implementation of the Mexican head is shown in figure 3. Figure 4 shows the wavelet algorithm for detecting signals. The following operations are shown in figure 4. 1. Wavelet processing of signals in interfering electronic communication. 2. Calculation of the Fourier transform. 3. The process of making decisions based on morphological analysis or visual analysis regarding the presence of a useful signal in electronic communications with noises. When estimating values of wavelet spectra of signals, the procedure of averaging values by time shifts was applied using the expression 3. When using wavelet processing expressions in the Mexican head base, an algorithmic support for signal processing has been developed for its detection in the form of algorithm which is shown in figure 5. The results of wavelet detection of signals in the base of Mexican head under the influence of noises with root mean square deviation at the level of 0 to zero point 0.6 volts squared in the form of spectra are shown in figure 6 to 9. Based on the results of wavelet detection, figure 6 to 9, it can be determined that the component of the wavelet wavelet spectrum of the useful signals is clearly localized in electronic communications with noises with different levels of RSD of noises per 500 displacement on all numerical scales. Statistically evaluated 3D representation of the signal spectra at the RMSD level of noises 0 to 0.6 volts squared is shown in figure 10 to 13. The average realization of wavelet spectra, figure 10 to 13, allow for more detailed comparative analysis of data in comparison with 3D representation of spectra. The use of the guide utility in the MATLAB environment made it possible to develop automated wavelet signal detection software with noises in electronic communications. The software interface and the detection result are shown in figure 14. The implemented mathematical algorithmic and software for wavelet detection of useful signals in interfering electronic communications based on wavelet processing with an mother base function Mexican had made it possible to increase the number of finches for detecting the type of wavelet spectra of 3D and 2D types that reflect the fluctuation process of signals and visually and quantitatively indicates the present absence of useful thing against the background of noises of different power. Thank you for your attention.